All right, let's talk about the unsung heroes of the industrial world. Deep inside almost every major industry you can think of, chemical plants, power stations, you name it, there are these incredible little devices working 24/7. They're called mechanical seals. And today, we're going to pull back the curtain and see exactly how these crucial components keep our world running safely and smoothly.
So here's what we're going to cover. First, we'll get into the basic job of a seal, why they even exist. Then we'll break down the two main ways to classify them. After that, we'll meet 6 of the most common types, put them side by side for a showdown, and then wrap it all up with the single most important lesson you need to know about choosing the right one.
Okay, first things first, let's talk about the fundamental problem. Anytime you have a spinning shaft going into a piece of equipment that's full of some kind of fluid, well, you've basically got a potential disaster just waiting to happen. And that right there is the entire mission of a mechanical seal. It creates this perfect running seal between that spinning shaft and the stationary part of the machine. Its whole job is to keep the product, whether that's water, oil, or some nasty chemical, from leaking out, and to stop all the gunk like dirt and dust from getting in. It really is all about safety, efficiency, and reliability. Now, there are a ton of different seals out there, and to really make sense of them, it helps to have a simple way to think about them. You can basically look at any seal through 2 key lenses: what it's physically made of and how it handles pressure. So, think of arrangement as the what. What are its physical parts? Does it have one big spring, a bunch of little ones, or maybe a flexible bellow? That's its arrangement. Design, on the other hand, is the how. It's all about the physics. How does it actually behave when the pressure gets cranked up? Getting this difference is absolutely key. And here's where design gets really interesting. An unbalanced seal is the simpler of the two. All of the process pressure is just smashing its sealing faces together. But a balanced seal? That's where some clever engineering comes in to relieve some of that force. This means it can handle way higher pressures and speeds without overheating and failing. Now remember that difference, because it is about to become very important. Okay, now that we've got that framework, let's open up the catalog and see how this all plays out in the real world. We're about to meet 6 different seal specialists, and each one is built for a very specific kind of job. First on our list is a true industry workhorse, the single spring seal. As the name suggests, its whole design is built around one single heavy-duty coil spring. You can see right away it's got that single spring arrangement and an unbalanced design. That combination makes it simple, really robust, and totally perfect for lower pressure jobs. We're talking up to 10 bar. It's especially great for thick, sludgy liquids that might clog up a more complicated seal. But what happens when the job gets a lot more demanding? For those higher pressure situations? Well, that's when you call in the multispring seal. And here it is, the key upgrade. Look at that. It's a balanced design. That one simple change is a game changer. It triples its pressure rating all the way up to 30 bar. This makes it the go-to specialist for high pressure pumps and even for holding a vacuum. Now, some jobs require let's say a very particular set of skills. When you're dealing with seriously corrosive chemicals, this is the specialist you call. Its secret is right there in the name, the Teflon bellow arrangement. Teflon is famous for being chemically inert. It just doesn't react with stuff. So this balanced seal becomes the perfect choice for handling aggressive acids and other harsh chemicals, even if the pressure isn't super high. Okay, what about extreme temperatures? What happens when things get incredibly hot or cryogenically cold? All the normal rubber and plastic parts in a seal would just fail completely. That's when you need the toughest specialist in the entire lineup. This one uses a metal bellow, but its real magic isn't what it has, it's what it doesn't have. There are no rubber O-rings, no elastomers at all. That flexible metal bellow does all the work, which allows this thing to operate at temperatures that would literally destroy any other seal. All right, now for a seal you've probably been around dozens of times and never even known it. This is the simple, effective little hero that lives inside countless everyday devices. With its straightforward conical spring arrangement and unbalanced design, it's pretty similar to the very first seal we looked at. It's definitely not built for high pressure, but its simplicity and low cost make it the absolute standard for millions of small water pumps. Think pools, homes, and light industrial uses. And last but not least, our final specialist, This one is all about combining some serious high-performance capabilities with making installation as easy as possible. Meet the cartridge seal.
So yes, its balanced design can handle some pretty high pressures, up to 25 bar. But its real genius is that cartridge arrangement. The entire seal, all the delicate parts, comes pre-assembled in one single unit. This completely removes the guesswork during installation, which is a massive deal for critical equipment like industrial reactors, where you just can't afford to get it wrong.
Okay, we've met the whole team. Now let's put them all up on the board, head to head, and really see how they stack up against each other. When you lay it all out like this, a really clear pattern just jumps right out at you, doesn't it? The two unbalanced seals, the single spring and conical spring, they're your general-purpose workhorses for lower-pressure jobs. The other four, the balanced ones, they are the specialists, each one engineered to tackle a very specific challenge: high pressure, nasty chemicals, extreme temperatures, or a mission-critical installation. It's really all about matching the right tool to the right job. So, after digging into all that technical detail, let's boil it all down. What's the one thing you absolutely positively need to remember from all of this?
And that is the bottom line, right there. Choosing a mechanical seal isn't just about picking a part out of a catalog. It's about truly understanding the pressure, the temperature, the fluid, and the machine it's going into. Get it right, and you ensure safety. You protect the environment, and you keep things running. But get it wrong, and you're looking at leaks, costly downtime, and sometimes a really, really bad day.
So, the next time you walk past an industrial plant, or maybe even just look at the pump for your pool, just take a second. Think about that unseen guardian spinning away deep inside. Now that you know the specialists, based on what that pump is doing, can you guess which one is on the job?